Good day, Ron here, and I have a series of videos for your entertainment, enjoyment, research. I create videos for learners, students of all sorts, whether you're in a college, university, or studying for some sort of certification exam. Mostly my videos are around cybersecurity. However, software and databases are right in that fold. So I do some videos like this about software and the whole environment. This one is creating a software engineering factory. Now, this is an introduction to several concepts, and each one of these concepts can be researched and explored a lot deeper than what I'm presenting. So I'm just presenting an overview. Also, there's other aspects that can be added to, subtracted from the 6 items that I'm listing here as well. But it gets you started down the path of thinking about how Industry 4.0, Manufacturing 4.0, however you want to call it, is integrated in the software development area and creates an entire constellation, for lack of a better term, of pieces and parts that can make the organization function fully and wholly. And so, what we're going to cover today, I'm focusing on a case study. Let's say we're focusing on semiconductor packaging. Now, semiconductors is a hot topic. It could be automobile manufacturing, EV factoring, or any other items regarding factories and production, or it could be simply a software environment in itself. So again, concepts, but the case study here that we're going to talk about is semiconductor packaging. Next, we're going to talk about Industry 4.0 and how that relates, sometimes called Manufacturing 4.0. The Web 3 technologies will cover some of that, what that is, how it's a little different than Web 2.0, the older stuff. Decentralized Autonomous Organization, DAO, how that is part of this constellation. And matter of fact, that's talking about blockchain technologies. That's right in the scope of cybersecurity as well. I just want to key that in. The software factory concept, a little different flavor and approach to software development. Certainly, the software development lifecycle, the secure software development lifecycle is part and parcel. And verification and validation, that's could be part of quality control, is part of quality control. It's an IEEE conversation, if you will. And so we'll talk about these 6 components and how really they sort of fit together. So the introduction right here, I will read some of these slides, but I'll fill in some of the concepts. As a concept and introduction, there are several aspects that are both evolving and congealing to help developers. And we can use developers in a very broad sense, hardware, software. Let's just keep it in that context. In the U.S., industries create a software engineering factory. Again, this is a starter concept. I'm using a case study. Each of the components addressed in this brief paper, so this is based off of Medium.com paper that I wrote, can be quite complex on its own accord. However, this discussion is to demonstrate on a very high level how these pieces can be leveraged and actually part of a whole constellation in industry. And industry, again, that's a very broad-based term. Could be manufacturing, could be software, could be pick your poison, if you will. So we've got this cyclical, and you can start off with manufacturing, Web3, DAO, software factory, verification, validation, packaging. So it's an iterative process, an iterative circle. How you build this out is really something on your own. If you're doing a research project or if you're in an organization thinking about this as a concept, drop me a note. I'll be glad to help you find some good research. I'll leave my contact information in the YouTube comments area. I think that's where it is. Anyways, semiconductor packaging. And really, I chose this as a general topic because I'm in Flagstaff, Arizona, and down in Phoenix, they're doing all kinds of build out. Taiwan Corporation is down there, Intel, they're all doing these large build outs. And part of it is to rehome, if you will, the semiconductor industry back on U.S. soil. Now, semiconductor packaging involves the use of various substrates, things like metal, plastic, glass, ceramic, casing containing one or many discrete integrated circuits and semiconductor devices. Now, if you're an electrical engineer, you know it depends on the environment that you're going to put that semiconductor in. And there's thermal properties, there's transfer properties, other electrical properties, static discharge, etc., with how you package items. And the more expensive items are used for things like space, technology, whereas the less expensive might be consumer products. It could be even the same darn chip process, but how it's packaged is based on the environment. While the individual components are fabricated prior to dissectioning and testing, that's again taking the wafer and slicing it up. The resulting components are packaged to provide better performance based on the environment and other platform factors. So while there are thousands of packaging types for semiconductors and integrated circuits, packaging is generally defined by the requirements of the user. So we always talk about the user, whether we're doing hardware design, software design, some sort of user interface. How does that fit form for the user itself? The environment that the semiconductor is in, where how it operates, and some of the standards. I focus a lot on DoD NIST standards for cybersecurity. That could be part and parcel. There's other standards based on environmental quality control, etc., based on the state, national standards, etc. There's also industry standards. I mentioned IEEE, so that would be one really strong set of standards itself. Let me see. Packaging, just a little bit more on packaging. Evolving standards are to be identified, including background radiation, high density, low emissions, substrate selection for optimal performance, transient air tolerance. That's we talk about electrostatic properties, conductance properties, etc., when we're designing chips, and other aspects that have to be part and parcel of the circuit design. Not only the circuit, but the platform and the packaging that circuit goes in circuitry. In addition, space flight, military applications, semiconductor packaging applications use hermetically packaged microcircuits, HPM, and more recently, both glass and plastic are encapsulated microcircuits. They're often referred to as PEM circuits, which in itself has evolving standards. As you can imagine, with lunar exploration, potential Mars exploration, all the satellites that we have going on, including EVs, so packaging is going to be quite different. And next, we have Industry 4.0 or Manufacturing 4.0, 4.0. I've heard it said many different ways. It's like potatoes. Anyway, Industry 4.0 is a framework that conceptualizes rapid technological change to industries and the resultant processes that are used by, in this instance, manufacturers. So Manufacturing 4.0. In fact, you can say this is the overarching discussion. We can put the other items in, but I wanted to present these 6 items and we'll summarize it at the end. Industry 4.0 boasts increased interconnectivity, smart automation in and between manufacturers, not only within the manufacturing environment, but the whole constellation, the processes, if you will. So if you think of Tesla as an example, if we're looking at semiconductor packaging, we need to look at the whole constellation, how if we are manufacturing chips with certain substrates, certain properties based on the environment, we talk about robotics with Tesla as well as EVs. What's going to be that platform, and how do we integrate? How do we look at the whole environment that Tesla is to provide them with a really solid product if we were a semiconductor manufacturer? Again, could be applied to many other manufacturing. I note down here, Industry 4.0 can be inferred as Manufacturing 4.0 in this context. So the challenge to Manufacturing 4.0, I switched it, is the effective integration of AI, artificial intelligence, robotics, and other technologies to foster automation while enhancing the efficacy for semiconductor packaging. Well, we'll talk throughout this presentation about other technologies that can be part and parcel, like blockchain technologies. The blending of technologies to support Manufacturing 4.0 in conjunction with other technologies such as blockchain, the Internet of Things, or IoT, Industrial Internet of Things, the machine-to-machine M2M communications, serves to actually, it increases automation, but it also enhances manufacturing. Self-monitoring of verification and validation, we'll talk about that V&V at the end, and that's tied to and associated strongly with quality management. And the use of smart machines that can analyze and diagnose issues without the need for human intervention. So really, we're leaning towards a smart manufacturing environment with little human interaction. Of course, this is why I tell all my learners, my students, if you will, look for the newer jobs that are working on AI, software engineering, not the factory floor items anymore, because a lot of that stuff is going the way of automation, and that's what this is really kind of all about. So Web3 technologies, really you could say we're in Web 2.0 right now, plus or minus, if you will. So Web 3.0 is an idea for the iteration of the World Wide Web that incorporates concepts such as decentralization, and a lot of that's managed by blockchain technologies. That it's a database technology. You can look at it that way. I'm not talking about digital currency. That's on top, if you will. That's very controversial right now. So thinking about blockchain technologies, IoT, trust and verification, if you will, with Web 2.0 as it exists, data and content are often centralized. So if you think of Intel, great company, but at one point in time, wherever their manufacturing environment is, wherever the engineering area is or are, if you will, all of that is really tied to a central headquarters, if you will. So what happens if we start breaking that down? Intel, I know they're working on a lot of this stuff, as well as other semiconductor areas, or even manufacturing in general. You break down, you decompose, you tear it apart, that centralization. It has a tendency to stifle innovation. Think about the large corporation, how innovative individuals are, engineers are in that environment, some great designers. It's hard sometimes getting through that morass of a very large hierarchy, given a group of companies that are involved in one technological market. So think about outside of Intel itself, Motorola, etc., all these other companies, the Taiwan Semiconductor Corporation, etc., how they sometimes share things and sometimes fight between each other. So there's the cohesiveness ends up being pretty stifled in Web 2.0. Web 3 technologies ends up kind of being that leverage to help out. So that brings into a concept, decentralized autonomous organization, DAO. And a DAO is sometimes called a decentralized autonomous corporation, DAC. So that's, again, one of those terminologies that gets switched back and forth. It's an organization with defined rules that are encoded into a blockchain. And I encourage you, if you're interested in blockchain, dig deep into it, because I think it, as we all know, it's going to be one of the driving factors, certainly in Industry 4.0. And it's controlled by the organization members. And in fact, think about it this way. You could have an organization that's a hybrid of Intel and Microsoft and that sort of thing. It's controlled by the agreements within the blockchain, and there's not necessarily influenced by a central office or central government or other outside agencies. It's a set of contracts that's managed and mitigated by blockchain technologies. DAOs are member owned. So again, you could have who's a membership. It could be a consortium of organizations. It could be a consortium of organizations as well as universities that are involved as well. So it can be managed by the blockchain technology. Now over to the right is really a construct diagram for blockchain in terms of the proposal, the voting, the development, and deployment. And it's iterative, as we can see here. However, keep in mind, later on I'll do another video on blockchain itself. This would be way too long of a conversation for this video. We're just doing an overview. And it looks I have the wrong label on this. This should say Software Factory up on the header. So Software Factory is a structured collection of related software assets. Now, we talk about this in C++ programming, even Python, C, pick your flavor of language where you have either a generalized library, specific library, etc., where you can pull objects into your code. So think of it in that way. Both the production and distribution of software components based on specific, externally defined end user requirements. So there's a little bit of a different twist there. If I'm creating financial software and I'm using C++, I can buy a whole library of financial objects. But think of it in terms of user requirements that we're building this software factory about, if you will. A software factory applies modern manufacturing techniques to the development and deployment of software. Now, I mentioned in here, again, labels wrong on here. I'm not going to go back and change it in the middle of recording. I'm going to plow through. So thank you for bearing with me. A software factory incorporates extensive tools, processes, and content using a schema to automate the development and distribution of software. So rather than being a little myopic, like let's say if we're doing C++ development or C# development or pick your flavor, that's kind of bundled in the context of that development environment. This cracks that open and think in terms of a Web 2.0 where we had hierarchy and now we're breaking it up with DAO. Likewise, the software factory takes that tight-fitting C++ or C# or Python and breaks it open so it's a lot more general and transitory between many environments. Now, I mentioned the SDLC as well as the SSDLC, the Software Development Lifecycle, and the Secure Software Development Lifecycle. Other rapid development models, we have the Spiral model, we have Agile, we have, going back years, the BOEM model, which is basically how software development started in terms of the Spiral model. But those can be part and parcel of the software factory. Now, if you're into the software aspect of this, I'm really stating that this is going to shed apart from the tight bundling with software environments and open up the ability for software to be created in a more fluid way. I am a little bit hesitating on some of these words only because it's another complex topic, but hopefully you get the gist. I will put out another video on this. The use of software factory will leverage prior software module and security development for firmware, component and application development through the semiconductor packaging environment using manufacturing 4.0 and the software factory process. So we're looking at a constellation of software components that can be tested, validated, verified, and moved around to different environments. Think of it like components in a factory rather than components in a piece of software. It's opening up that egg, if you will. So verification and validation, V&V. This is good stuff. I've taught a few courses on this stuff. It's really married with or linked up to quality. A lot of times when I was teaching V&V, it was leaning towards verification and validation of software engineering projects. So keep that in mind. Again, bad label. Verification and validation. Again, over to the right-hand side, that's an IEEE diagram. The requirements analysis, high-level design, low-level design, the coding. Over to the opposite side, system testing, integration testing, unit testing. Again, that all flows together. Coding from the bottom up, and you get the requirements analysis, system testing. And in a way, when we talk about this in the verification and validation course, there are some implied iterative aspects to this. Again, the SSDLC, SDLC, as well as verification and validation kind of work hand in hand. Oh goodness, the IEEE has adopted the Project Management Institute's PMBOK as part and parcel of this. And you'll see this diagram in the PMBOK. Validation is the assurance that a product, service, or system meets the needs of the customers and other identified stakeholders that could be users within the organization. It involves acceptance and suitability testing with external customers. Internal is often done primarily having the external customers, perhaps other consultants involved on the validation of the software product, as well as the hardware components that are also put together by the manufacturer. Verification, the evaluation of whether a product, service, or system complies with a regulation, requirement, specification, or imposed condition. It's often an internal process. Contrast that with validation. So it's closely matched, V&V. However, it takes on a different aspect of regulation, compliance, and those sort of aspects. Again, V&V, sorry about the label heading, I'm going to move forward, is involved with quality process. I mentioned ISO 9000, I mentioned other software, 27001, other aspects as well. In this instance, in our case study, semiconductor package through a V&V process is verified that a given module or component, hardware and software, fulfills its intended purpose. Components are sourced from approved vendors. That's the compliance, if you will. DoD has certain standards. You can't go out and purchase hardware, software through some vendors that are known adversaries of ours and suppliers. V&V can be an essential part of the DAO construct and can be mitigated as such. In other words, think about the agreements that are formed in the blockchain environment. Verification and validation can be part of that contract, and it should be. It should be. As a point of conclusion, industry in the United States is shifting to more of a domestic calling. It's rehoming a lot of our factories. And in this case, we were chatting about the software, hardware, the whole constellation for semiconductor production. So you can take these 6 items and look in a different scope at another environment, if you will. The concept in the paper briefly outlines the 6 highly technical aspects. This is just a summary. So this is what we covered: semiconductor packaging, Industry 4.0, Web 3.0 technologies, how that contrasts with the current web technologies, DAO, decentralized autonomous organizations, software factory concept, and that includes SDLC, Spiral, BOEM, Agile, pick your flavor, verification and validation that could apply up the chain to hardware and software. Again, these are 6 components, mix and match based on your environment. An introduction, you can interject other aspects that you read about here to build that constellation to support the environment. Send me a note, certainly, there, like the video if you do like it. Send me comments, suggestions, other topics you would like me to cover. I will go over some of these aspects in a little more detail. This is for you who are studying for a class, looking for research information, doing some sort of consulting, getting new ideas. Let's have a conversation. I'm here to support you and glad to help. Signing off, and talk to you soon. Bye.